Okay, so there are a whole bunch of laws that you need to know when you're working with gases. Most of them have just two variables in them, and the first one we're going to take a look at is Boyle's law. Boyle's law looks at the pressure and volume relationship of gases. That's a comma. Pressure-volume relationship. And since there are four variables which describe a gas, pressure, volume, the number of moles, and temperature, that means if these two are changing, the number of moles and temperature must stay constant. Whenever you do that, you have two variables. You can plot one on the x-axis, one on the y-axis, and see if you get a straight line. Scientists are very fond of straight lines. Anyway, so let's take a look at two cylinders. They're hard on the sides, and there's a piston in each one, and it can change the size of the cylinder. So we have volume 1 and volume 2. And we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gas molecules in here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gas molecules in this one. One way of looking at pressure is how often the gas molecules collide with the sides of the container. V1 is twice as big as V2. Let's call this 2 liters. Let's call this one 1 liter. So if this is twice the size of this second smaller container, the particles are going to hit the sides of the container twice as often in the case of V2 as they are in V1. So that we can see as V decreases, pressure, or the number of times the gas molecules hits the side of the container, goes up. So as volume decreases, pressure increases, and as volume increases, pressure decreases. We're going to call volume the independent variable because it's the one we can change, and pressure is going to correspond with it. When we change the pressure, if we change the volume, the pressure will respond. If you want to state Boyle's law mathematically, you can say P1 times V1 equals P2 times V2. Pressure 1 times volume 1 equals pressure 2 times volume 2. The thing you have to be careful about here is that the pressure units on both sides are the same, and the volume units are both the same. It doesn't matter what they are, but if this pressure is in atmospheres, this has to be atmospheres. If this is torr, this has to be torr, so you might have to change one or the other. Same thing with volume. If this is in milliliters and this is in liters, you're going to have to change them. It doesn't matter what you change them to, but they will have to be the same. So P1, P2, same units. And V1 and V2, also have to have the same units. So let's work a really short problem with this. What I would recommend doing is taking all these equations I will be giving to you, I think there's about 7 of them, and putting them in one spot in your notes. Just leave a little 3x5 space, and every time I give you one of these, put the next one in there. It's a lot easier to find the one you want if they're all together. Okay, so let's take a look at a problem. You have a container, with a volume of 600 milliliters, and its pressure of 760 torr. Okay, so this is V1, this is P1, and what you want to do is you want to calculate the pressure that's P2, when the volume changes to 800 milliliters. So that is V2. So you have this equation, P1 V1 equals P2 V2. And what we're looking for is V2. So I'm going to rearrange the equation. You can put numbers in first before you rearrange it, except I don't like to do that. I'm solving for P2. So I have P1 V1 divided by V2 equals P2. Now I've labeled things in my equation, so I know P1 is 760 torr. V1, or V2 rather, what did I just do? V1 is 600 milliliters. V2 is 800 milliliters. And I'm going to multiply 760 by 600. Then I'm going to divide by 800. So obviously, looking at it, you know the pressure has to be less than 760. And when I do the multiplication, I get 570 torr. All right, that's the answer. So that's Boyle's law. Let's just go on.